Lastly, let's talk about enthalpy change, standard enthalpy change of formation. Okay, I like to use water as an example. Let's talk about the definition of standard enthalpy change of formation of water. I would like to use water as an example. Now, what does this term means? It means that is the enthalpy change. Now look at the definition, okay? Is the enthalpy change when, underline, 1 mole of the substance forms from its constituent elements in their standard states under standard conditions. Okay, that means I would use water as an example. Is the enthalpy change when 1 mole of water is formed from its constituent element. How to spell? constituent. Okay, constituent elements in their standard states. And then lastly, standard. So you must end up your definition by telling me under standard conditions. Do you understand? Okay. Now, first of all, do you remember what is the meaning of standard conditions? Tell me. If you have forgotten, please turn back to the previous chapter. This chapter, and study what is the meaning of standard conditions. Okay, and then look at the equation. Now, first of all, highlight the definition. 1 mole of water is formed, and then underline from its constituent elements. That means water in this situation is the product. I need to write down water in the product side. From its elements. What are the elements of water? Answer is hydrogen gas and, pay attention, O2 gas. Now don't tell me O is not an element. It's not the formula for the element. Next, balance the equation. Refer to the definition. 1 mole of water. So please don't change the number before water. Keep it as 1. Then 1 H2 and half O2. Do you understand? It is the definitions of the standard enthalpy change of formation of water. Do you understand? Now, what is this value? It is negative 285.8 kilojoule per mole. First of all, what does it mean? Per mole of what? Per mole of water. That means when 1 mole of water is formed from its constituent elements, 285.8 kilojoule of heat is released because of the negative sign. Understand? When 1 mole of water is formed from its constituent elements. Okay, so you are required to memorize this definition. Must be asked, always ask in the examination. Here, let's look at some learning tips. in the thermochemical equation representing the standard enthalpy change of formation, the coefficient of the substance that forms must be 1. Underline. Must be 1. Coefficient of the substance that forms must be 1. Do you know why? It is because of the definition. Understand? Now, look at some tips. This definition has been asked many times before. A-level 2004, A-level 2008, AS level 2010. So very important. Understand? Turn to the next page. Because the heat of formations of water from its element is exothermic. So let's talk about its enthalpy level diagram. Now I must emphasize again, please label the y-axis, it is enthalpy. X-axis is the reaction pathway. Again, you may miss the x-axis. Because the reaction is exothermic, therefore the enthalpy of the reactants should be higher than the enthalpy of the product. And look at the red arrow. The red arrow is pointing downwards. Understand? In this situation, when 1 mole of water is produced from its constituent elements, net 285.8 kilojoule of energy is released. Now let's look at the formation of NO2. Look at this equation, okay? Here, 1 mole of NO2 is formed from its constituent elements. Its elements are nitrogen and oxygen. How to write down the equation? We need to keep this number, this coefficient as 1, so that half N2 is involved in the equation. Its heat of formation is positive 33.9 kilojoule per mole. Now what does it mean? When 1 mole of NO2 is formed from its constituent elements, 33.9 kilojoule of energy is absorbed. Okay? Now let's write down the term for this enthalpy change. It is called standard enthalpy change of formation of NO2. Bear in mind, states are very important. Is the enthalpy change when 1 mole of NO2 is formed from its constituent elements. Elements are N2 and O2 in their stable physical state. I will explain this sentence later, okay? Under standard conditions. Now bear in mind, you are required to memorize this definition. Don't simply look at the video. Pause the video and please write down the definition in detail. Now because it is an endothermic process, so let's look at its enthalpy level diagram. Again, what is the y-axis? Enthalpy. How about the x-axis? Reaction pathway. Because the reaction is endothermic, therefore the red arrow should be pointing upwards. Understand? Okay? Now, please copy down this note. Now, the positive standard enthalpy change of formations of NO2 shows that NO2 is energetically unstable with respect to its constituent elements. Energetically means energy. Compare their energy. So please highlight energetically unstable compared to its constituent elements, because NO2 will have a higher enthalpy than its constituent elements. In describing the stability, we need to add energetically. That means refer to energy. Okay, this energy is higher than the energy of its constituent elements. Is there any problem? How about in this situation? How about this one? H2O has a lower enthalpy than its constituent elements. So, can you tell me? H2O is energetically, please put down this sentence. H2O is energetically more stable with respect to its elements. Okay, because water has a lower enthalpy than its elements, energetically more stable with respect to its elements. Next, let's talk about the standard enthalpy changes of formations of all elements. Please highlight all elements. Now, if we talk about the standard enthalpy change of formations of all elements in their standard state, they are 0. Why? Now, because we need to talk about the standard enthalpy change of formations of H2. H2 itself is an element. From H2 gas to H2 gas, there is no enthalpy change. Therefore, in this situation, it is 0. Similarly, Br2 is an element. Okay? Standard enthalpy changes of formation of Br2 element is also equal to 0. Because look at the equation, nothing changed. Therefore, enthalpy change is equal to 0. Similarly, for sodium element. Understand? If we have elements, then standard enthalpy changes of formations of all elements in their standard states are 0. Is there any problem? Next, let's continue. Let's look at this table. The standard enthalpy change of formation of graphite is 0. The standard enthalpy change of formation of diamond is not equal to 0. The standard enthalpy change of formation of hydrogen is equal to 0 because hydrogen is an element. The standard enthalpy changes of formation of oxygen is also equal to 0 because oxygen is its elements. Understand? Similarly, look at the right side of the table. The standard heat of formation, standard enthalpy changes of formation of ozone is not equal to 0. Do you know why? Standard enthalpy changes of formation of Cl2 0, 0, 0, because all these are elements. Now, let's look at the think about. why are the standard enthalpy changes of formation of diamond and ozone are not zero? Now, because under standard state, carbon refer to graphite, not diamond. Oxygen refer to O2, not ozone. Now that means if I need to write down the equation for the standard enthalpy changes of formation of diamond, this is the equation, formation of diamond. So please write down diamond on the product side. Formation, that means from graphite. These two substances will have different enthalpy, so there is an enthalpy change, and in this situation it is equal to plus 1.9 kilojoule per mole. Plus 1.9. If I draw an enthalpy level diagram, bear in mind every time label the y-axis enthalpy. X-axis, you may miss the x-axis, but I like to label the x-axis as reaction pathway. Endothermic, pointing upward or downwards. Endothermic should be pointing upwards. So here is the enthalpy of graphite, then pointing upward. Here is the enthalpy of diamond. Is there any problem? Now, similarly for ozone, can you please write down an equation for the standard enthalpy changes of formation of ozone? Now, please pause the video and try by yourself. Let's check the answer, okay? Formation of ozone. That means ozone is in the product side. From its constituent elements is oxygen. How to balance this equation? Bear in mind, keep the substance, the coefficients as 1. Don't change this number. So we need 3 oxygen. So in balancing the equation, please put 3/2 before O2. This formation of ozone is positive 143 kilojoule per mole. What does positive mean? Positive means endothermic. And again, please draw the enthalpy level diagram.